Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of reverse engineering, specifically tackling the VanMoof e-shifter mystery. Get ready, folks, because it's going to be a wild ride.
Yeah, this VanMoof e-shifter, right? The infamous component that supposedly sunk the company? I'm itching to hear how this guy cracked the code.
Exactly. So the author, Mike Coates, is trying to reverse engineer this thing. Because, let's face it, those shifters are notoriously unreliable. He starts by figuring out who's talking to whom. Is the bike sending the request, or is the e-shifter initiating the conversation?
Ooh, a classic communication protocol puzzle. So how did he solve it?
Using an oscilloscope and some clever jumper removal on a spy. Brake! Inject! Board. Think of it as a superpowered eavesdropping device for circuits. He determined that the bike is the one sending the requests. No signal from the bike, no response from the e-shifter. Simple, yet elegant.
I see. So the bike's the bossy one, huh? Sending orders, and the shifter just obeys, or tries to, until it fails spectacularly. What about the speed and format of the data?
Ah, yes. He used a logic analyzer, a Glasgow Digital Interface Explorer, to be precise, to capture the data stream. Then, using GTK Wave, he visualized the data, zooming in to identify individual packets and bits. Turns out, it's a 9,600 bits per second signal, with packets around 80 and 70 bits long.
9,600 bits per second. That's pretty slow by today's standards, isn't it? But what's the format?
That's where it gets really interesting. He figured out it's likely a 10-bit byte format, which is unusual but makes sense when you consider UART framing. A start bit, 8 data bits, no parity, and a stop bit. That adds up to 10 bits. Clever, right?
Very clever. So 8 bytes for the request, 7 for the response. But what are those bytes saying?
Using PulseView, he decoded the bytes. He noticed repeated bytes at the start, suggesting headers, and some low values followed by high values, which hinted at a checksum. And guess what? It's Modbus.
Modbus, the industrial communication protocol? That's unexpected. What was the message?
The bike is essentially asking the e-shifter to read a register at a specific address. The response indicates that the register was read and returned a value of hexadecimal 0200 or 512. The mystery remains. What does that value mean?
That's a cliffhanger. So does he need to understand the meaning of that value, or can he just spoof the response?
That's the million-dollar question. He's planning to log an entire bike ride's worth of communication to see if he can figure it out. Or maybe he'll just create a spoofed response and bypass the whole thing. Stay tuned for the next episode.
This is amazing. Thanks for breaking down this complex reverse engineering project for us. It's a real testament to the power of persistence and clever analysis.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Bye!
Bye-bye.